Hello, algebra students. So this is the Indicator 17 review. This is a really good preparation for the test, but I really suggest that you work these problems before watching the video. I had a professor that used to say mathematics is not a spectator sport. You know, you learn by doing the math yourself. So if you don't have time, it's late at night, and you haven't done the problems yet, you can benefit some by watching the video without doing them. But that's just really not the way to get the most benefit from it. So much better to do the problems first. Okay, so let's look at these. And it's helpful to do practice like this with all the different kinds of problems mixed up. You know, in the homeworks, the first two homeworks at least on monomials, you had just a certain kind of problem, and then on the last one, they were different kinds of problems mixed up, and I could tell by grading them so far that makes it harder. So this is good practice. Okay, so let's look at this first one. This is multiplication, so we add exponents. And I'll write it down here. I like to do them in alphabetical order, so we'll look at the A's first. So we have a base of A, and we look for all the A's, and we see we have a 3 here and a 4 here, and that's it. So add 3 plus 4, and that's 7. And let's look at the B's. Well, with B as a base, we have this 2 here, and we have this one does not have an exponent, so it's 1, right? So that is 2 plus 1 is 3. And with C, we have this one and this one. Neither have an exponent, so it's 1 for each of those, right? So 1 plus 1 is 2. Okay, so that's it. This is a good one to look at. One of the things I want to emphasize is be aware of what's going on. Be aware of what exponentiation means while you're working these problems. Let's just look at those A's and zero in on the A's. And we have an A to the third power. We also have an A to the fourth power. And so just that part, what is that? And we said it's A to the seventh. But remember what this exponentiation means. It means repeated multiplication. So that is, okay, A to the third, right? A times A times A, repeated 3 times. And then this is A to the fourth, okay, repeated 4 times. So altogether there are 7. So it makes sense. Just be aware of that. I think it helps to cut down on mistakes. If you would subtract exponents here instead and get A to the first, then hopefully you'll be aware, well, wait a second, we're multiplying here. There's got to be more than just one A. If I had A to the third, that means I'm multiplying 3 of them. And if I have A to the seventh, I'm multiplying 4 more. So there's a lot of A's there. And maybe you'll catch yourself if you use the wrong rule and you subtract when it's multiplication, when of course that's when you should add. Okay, so I'm going to erase those so they won't be part of the notes, but because it's not necessarily clear if you don't have someone telling you why I wrote those down. Okay, so next one is exponentiation of a monomial. So you have this monomial, and we're raising it, the whole monomial, to the power of 3. So that 3 is applied to each thing inside. It's applied to the 6, and then it's applied to the m, to each variable. Well, in those cases, you multiply the exponent, right? So you have m as a base. It has a 3 exponent, and then that's times this 3. So 3 times 3 is 9. N has just a 1. So 1 times 3 is 3. And P has 2. And then we have the 3. So 2 times 3 is 6. And of course, we have to actually calculate 6 to the third power. That is 216. Okay, so there's that one. Now I skipped 2, so let's go back and do number 2. We'll try to do the rest of them in the proper order. This one has numbers, so divide the numbers. You have negative 18 divided by 3. That's negative 6. So just try not to make these numbers any harder than they are. You just treat that as a fraction. If you have negative 18 over 3, that means negative 18 divided by 3, negative 6. Okay. X. Subtract exponents because it's division. You have 6 in the numerator, 1 in the denominator, so subtract, and that's 5. You have y in the numerator and 3 in the denominator, so subtract, and that is 2. In both cases, the larger exponent was in the numerator, so that's where our base is when we're done, right? We have x in each the numerator and the denominator, but the larger exponent is in the numerator, so the leftover x's, so to speak, are in the numerator. Let's see what that looks like focusing on the y's, just as a sort of refresh your memory, because we do want to be aware of what's going on as we're doing these problems. So we have this y to the 5th over y cubed, and we could, just like we did a while ago with the a's in number 1, we're going to look at the y's in number 2. Okay, so that's y times y times y times y times y, repeated 5 times in the numerator. Y times y times y, repeated 3 times in the denominator. And we can cancel, right? So you cancel 3 of those y's from the numerator. There's none left in the denominator. The numerator had more. It had 5. The denominator only had 3. So 5 minus 3 is the 2 that are left over, and that's why that exponent is 2. So you're not going to write this kind of thing down every time, but I'm doing it on a couple of these problems just to remind you of what's going on. You're not going to write this down, but you can be aware every time of what's going on, so to speak. When you have division, you're going to be canceling, and you have the leftover, so to speak, in either the numerator or the denominator. Now that's helpful because, again, if you were to forget and multiply instead of divide, you would have something like y to the, I'm sorry, if you were doing if you use the rule for multiplication instead of the rule for division, you might add the exponents and get y to the 8th. And then if you're aware that division means canceling, then you see that y to the 8th and go, wait a second, how did I get more? I only had 5 in the numerator and I had 3 in the denominator, and now I have y to the 8th. I shouldn't have more because I should have canceled some, and so I should have less. Okay, so hopefully that helps to just remind you to be aware of that. Okay, so the rest of these we'll do more quickly. We may look at one more with the canceling, but we won't do it on most of them. Okay, so here we have raising this monomial to a power. So we have the m raised to the fourth power. Okay, because it's 1, and 1 times 4 is 4. The n is to the fourth, and multiply 4 times 4 is 16. So that's that one. Okay, number 5. So multiply the numbers. This is multiplication. Negative 6 times positive 7 is negative 42. And to look at the variables now, we have a, we have a 2 and a 5. We add them, so that's 7. So a to the 7th. And b, we just have the 1b. So we have that exponent b squared. Number 6, that looks pretty quick. 3 to the negative 2 power is 1 over 3 to the positive 2 power. That's really what negative 2 means. It means 1 over that base to the positive 2. And so that's 1 over 9. Okay, number 7. Subtract exponents again. With the x's, there's more in the numerator. So we have x to the 5th, 7 minus 2. With the y's, there are more in the denominator. Okay, so the leftovers, so to speak, after we cancel are in the denominator. And 2. 5 minus 3 is 2. We could look at those y's again. In the numerator, we have y cubed, which looks like that. In the denominator, we have y to the 5th, which looks like that. So we cancel. We're going to cancel everything from the numerator, but in the denominator, there's still y times y. That's y squared. Okay, so again, be aware of what's going on. You're doing division, and so you see these exponents, and you realize I should have some leftover y's in the denominator. I won't have any in the numerator. Okay. And I won't have any exponents bigger than what I already have, of course, because I'm going to subtract. Okay. Whoops, don't want to erase that. Okay, number 8. 4 to the 3rd power. Okay, that's just 4 times 4 times 4. That comes out to 64. Okay, number 9 looks like a big, difficult problem. It's not too bad. Multiply the numbers. 1/4 times 2 times 2. So that's just arithmetic, right? And you can do them in any order. So a convenient way to do this is take 2 times 2 is 4, and then take 1/4 of 4, which is 1. You may not notice that, and you may not think of that. You might do them in order, and that's fine too. You could write this off to the side somewhere because it's such a big problem. You could do this calculation separately because you're just multiplying the numbers. 1/4 times 2 times 2. Well, from left to right, 1/4 times 2 is 2 over 4. That's times 2. Then you could do this a couple of ways. I would probably reduce the fraction 2/4, and that becomes 1/2. We're going to multiply that times 2. 2's cancel, and it's just 1. Okay, so when we multiply that out, we get 1. We can leave that there because that'll be clear where that came from. So 1/4 times 2 is 1. Since it's 1, we don't have to write it down. Let's do the variables now. So we have our a's. Let's gather all our a's. So altogether, that is 5, right? 2 plus 2 plus 1 is 5. So it's a to the 5th. B, we have here and here, so add those together. It's b to the 12th. And then we have a couple of c's. We have c to the 1st here, and we have c to the 2nd. So add 1 and 2, and you get 3. A to the 5th, b to the 12th, c to the 3rd. Okay, number 10. Raise this to a power. So we have 2 raised to the 5th power. Go ahead and write that down. A to the 3rd raised to the 5th, multiply exponents. A to the 15. Okay, then b to the 2nd, and then that's to the 5th. So multiply and you get b to the 10th. And then c to the 5th, multiply exponents. 5 times 5 is 25. Okay, so the 2 to the 5th, we need to calculate that. That's 32. So I think the rest of that is right. Okay, let's look at number 11. Okay, so we have numbers. Carefully multiply the numbers. -3 times -4, that's positive 12. We'll just look at those variables. X, add exponents. X, you have 2 and 4, make 6. What about B? You have 1 plus 3 is 4. Okay. Number 12. Okay, divide. 32 divided by 2. That's 16. Okay, look at our m's. We have m to the 2nd and m to the 2nd. It's a pretty common mistake on homework is you guys a lot of times will just go ahead and put that variable there, m. You figure, well, I've got 2 there and 2 on the bottom. It's just m now, right? The 2's, maybe you're thinking of it like this. Maybe you're thinking the 2's cancel sort of and just leave an m or something like that. But that's not what's going on. Let's look at those m's. You have m times m in the numerator, right? M to the 2nd power. You have m times m in the denominator, exactly the same number of m's. Okay, so they're all going to cancel. There are no m's. Okay, so we got to get rid of this. There are no m's. Okay, so with the n is the next variable we can look at. There are more in the denominator. There's 6 and only 4 in the numerator. The same with the p. So in the denominator we have n to the 2nd power, right? Because 6 minus 4 is 2. Oh, sorry, p is larger in the numerator. So with p, we have 6 minus 2 is 4, and that's in the numerator. Okay. I'll briefly just show how we could do this with negative exponents, right? As long as we don't leave the negative exponents. If you like to do it that way, it's fine. So you take 32 divided by 2 is 16. And then you can just go through and not worry about which one's bigger. Just subtract the exponent in the numerator minus the exponent in the denominator. Just, you could do that every time, regardless of which one's bigger, and then go back and take care of your negative exponents. So if you do it that way, let's see, for m, you have 2 minus 2, that's 0. We could even write it down if we want to, even though it's not going to be in our answer, right? M to the 0 means there are no m's multiplied at all, so we don't write it down. But for intermediate, we can. M to the 0, of course, is 1. So, we can write it down. It means 1. We're just not going to leave that in our answer because it's not simplified. It needs to be changed to 1 to simplify it. So go to the ends. 4 minus 6, that's negative 2. And then we go to the p's, 6 minus 2, and that's positive 4. Okay, so now we write this, simplify it. Our m, we don't write down at all, right? Our n, we put down in the denominator and make it 2. And for p, it's positive, so we leave it in the exponent just as it is. And of course, we get the same answer. So which way you do it is completely up to you. Okay, so let's look at these ones with the geometry, the triangles and rectangles. Express each area as a monomial. You have to know the formulas, right? Notice on this review, there is no formula that says area of a rectangle is length times width. Okay, you guys know the area of a rectangle, right? So it is length times width. So the area of this first one, we could write A if we want to, multiply length times width. So 5 times 6 is 30. Now we look at each base, A, add the exponents for A, 3 plus 3 is 6. And you get to B, add the exponents, 3 plus 1 is 4. And that's it. So let's look at the last one. Area of a triangle is 1/2 the base times the height. So 1/2 times the base, 4x squared times y squared. I'll go ahead and write it all down this time, times the height, which is 3x squared. Okay, now we can multiply. We're going to multiply the numbers. Just multiply them left to right. It's 1/2 times 4 times 3. 1/2 times 4 is 2, times 3 is 6. Then just look at the variables one at a time. Add the exponents that have the same base. So base of x, you have 2 and you have 2, and that's it. 2 plus 2 is 4. And for the y's, you just have the y squared. Just this one instance of y, and it's squared. So that's it. And those are our two areas. Okay, this is a good preparation for the test. Like I said, if you're able to do all of these problems, for the quiz, I mean, if you're able to do all these, you should be in pretty good shape for the quiz.